see, live. Okay, live. We look to be live. Let's close this before we get too much feedback. And let's start. Okay. Hi everybody. So today we're gonna do this. Given an n by n matrix, rotate by 90 degrees clockwise. For example, giving the following matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 should return 7, 4, 2, 7, 4, 1, 8, 5, 2, 9, 6, 3. Okay, so for example, we can see that the 3 should be here, right? So this gives us like kind of one coordinate. So let's first calculate where coordinates should go. Clockwise, and we go x, y, and n. Okay, and let's think. Okay, so if you think about it, 3 have been going here, 9 has been going straight here, and I think let's kind of actually get another example. Okay, so let's have an example that's a bit bigger. So let's do 1, 2, 3, 4. 1, 2, 3, 4, 5, 7, 6, 8, 9, A, B, C, D, E, F, G. Okay, I'm using letters just so that everything is still one character. So it's easier to read. Okay, so let's think. What would that mean? Okay, so we have, so see that the first row should be like the last column. So 1, 2, 3, 4. And now 5, 6, 7, 8. And what next? 9, A, B, C, and then D, E, F, G. And the reason I wanted to have 4 rows is to kind of figure out what goes on with the middle rows. Right. Let's tighten this a bit so that it's easier to understand. Tip, tip, tip. But this is a nice thing about using Jupyter. You can use it for the documentation examples as well, because it supports Markdown. Okay, so this is rotating this matrix by 90 degrees clockwise. Okay, so let's see what happens to 2. 2 moves from here to here. Now what happens to 3? No, I don't know what happened. Okay. 3 moves from here to here. Okay, so I think, right, so if you notice, this is from the end, right? So x, so if it's the first row, it will go to the last column. So return. So the new x coordinate will be the y coordinate, but n minus it. So n minus y. And then the x coordinate is just moves to be the new y, right? So if you look at it, if it's 2 here, it's gonna be 2 here. Okay, or if it's 6 here, right? going to be 6 here. So see that the x coordinate becomes the y coordinate. That's x. Okay. So, and we can check, right? So here we go. And now let's do xy equals clockwise. Let's first check that 4 goes into the right place, right? So if we wanted to know where the 4 goes, so 4 originally was at the y's coordinate was 1 and the x coordinate was 0, so clockwise 0, 1, and the length of the array is 3. This can't be n minus y, right? Because if y is 0, that will give n, that's too big, so that's going to be n minus 1 minus, okay. Okay, and now let's do r y x 2. What are y and x? 0 and 1. Nothing should be its own clockwise rotation, that it's right in the middle. So this is wrong. But I don't think that will make it any better. Yeah, so first of all, it's clockwise 1, 0, right? Because it's x and y. Let's move this back because I think it's right. Three, 1. Yeah. Up. So it should be. Okay, so clockwise from 1, 0, right? So that should be 2. And yeah, it should move to where 6 is. Right? So that's okay. Yeah. Okay, so I think that's correct. Okay, so now we will start with like doing a copy. And again, like I always suggest you tell the interviewer, okay, I'm gonna start using this more space, and then we can rotate clockwise, and then we can see if we can do it in place. But first, let's use extra space. R. So let's first calculate n. N equals length of R. Now let's prepare the return. times n for I in n. And let's even already we can do return ret and do rotate clockwise r to see that at least it gives us a 3 by 3 array. Yep, and that's good. Okay, so J, so we already have rotate clockwise, right? So we do, let's keep with the x and y notation. Okay, so let's do new y, new x equals clockwise x, y, n. And now let's do ret of that's new x, new y, right? We always tell them in this order. Ret of new y, new x equals r of y of x. And let's do a nice printout for row in just to kind of see. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what we should have done. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is great. And the other benefit that rotate clockwise gives us is now it can use, even though it's inefficient, it can be used in tests, right? Because I know that rotate clockwise is correct, even if it's using more space than it should, I still can use it in tests. I can check against the original and see that it gives the same result. Okay, so let's do efficient rotate clockwise. And the trick with efficient rotate clockwise is to realize that if you think about it, for each element, like let's say we have 3 goals, right? Or let's say where 1 goes here, right? Let's 3 goes here is fine. So 3 goes here, and it goes to where C was. C goes here to where E goes. E goes here to where 5 goes, and 5 goes here to where 3 goes, right? So they're in a loop, and it makes sense. If you rotate things 90 degrees 4 times, they become the same thing. Okay, so just make sure for each element, we can just calculate the cycle, then do that cycle, and then put the things back where they should. So let's try that. And because this is in place, right? So if we make bugs, we'll like destroys the array. I'll kind of reinitialize it before we call the function. And since the function doesn't need to do anything, and then we'll do for row in R, print row. Right, and obviously this is not going to rotate, but this gives us the general shape, right? And now, yeah, let's do new R equals rotate clockwise R. We can kind of print both of them at the same time to check that they're the same. Obviously right now they won't be the same. Row 1, row 2, print row 1, row 2. Okay, and when we do it, it should be the same, right? So that's kind of a nice visual aid, right? So let's think where things go, right? So, but we notice that if we do this thing, then we might, right? If we do for x in range n, then when we calculate the cycle, and the cycle includes 4 other things, and if we rotate each time we hit, then we'll rotate each thing back to where it was before, right? So we want to look for the cycle, right? So for in range 4, cycle equals just clockwise, right? Clockwise x, y, and we'll do print cycle here, right? So that's obviously not gonna help much, right? Because we're not actually rotating anything, but we need to call the function, of course. Efficient rotate clockwise. Yep, and we need to start with n equals len of array. Okay, so I don't want to print the cycle here, I want to print the cycle here. So once it's done, okay, so 0 0 2 0 2 2 0 2 0 1 1 0 2 1 1 2. Okay, so these are the cycles. But if you notice, this cycle that involves 0 0 will also come here. It's the same cycle, just shifted, right? So we should do like range and divide by 2. And I think we want one of them divided by 2 and one of them kind of ceiling divided by 2. So let's see. Do a little visual inspection. Okay, and now what do we do with the cycle? So now we do things equal r of y x for x y in cycle, and then we do rotate, right? So 0 0 goes to 2 0, right? So we do things dot pop 0, things dot append, and then we do for x y val in zip cycle things, and I'm pretty sure there's still a bug here, but we'll see after we try to rotate what things we rotate correctly and what things we rotate incorrectly. So ploop ploop ploop, r of y x equals 1, right? So this does basically loops to things, and I should probably have used the DQ, but it really doesn't matter because it's just 4. So this part as well as this part, you can think of it as constant time. But this does need to be inside this for loop. And I'm gonna disable printing the cycle for now. So let's see how this works. Okay, so as you can see, I failed. New array is correct, and this 1 2 3 4 5 6 7 8 9, I think I wrote it counterclockwise, but that's an improvement, right? Because in that case we can do is this still gonna be, this is gonna be easier than I think. Yeah, this is, yeah, so instead we're gonna shift it the other way, right? And this is why it's so useful to have this kind of test. So what would it look like to shift the other way? Things of 3 plus until 3. Yes, plus this should be array of 1 element. Okay, 1 2 3 4 5 6 7 8 9. Okay, so that worked pretty well. Actually better than I thought. Huh. Yep, let's try another one. Okay, so let's add one more element here. So I'm gonna just add like very big numbers to not mistake. 11, 12, and of course we need another row. Another row. Okay, so that's 13, 14, 15, 16. We don't need this anymore. We definitely still want that, and we want to reinitialize R. Okay, so this what did I forget to redo? This. No. Okay. Oh, doing these things again, we rotated it. Okay, so okay. Now, okay, so now this it's the same, right? So this is efficient clockwise, rotate clockwise R, and okay, now even if your interview is kind of annoying, it's gonna be hard to find like better ways to do that. So I'm gonna still try to be annoying because a good interviewer is really annoying. Say, mm, that seems a lot to track here. This code is kind of complex. Can you make it simpler? And I think the only other thing I can do to make it simpler is to realize that rotating clockwise is like mirroring and then remirroring, I think. Okay, so let's do def mirror on X. And again, we'll do n equals length of array. And now what we want to do is for X in range equals n minus 1 minus y of X. And just for fun, let's actually kind of put a test right here. So this is obviously mirroring in place. And let's do for row in R print row. That doesn't look right. Mm. Let's do it for just one row. Let's see what happens. Okay, so let's remember this is the first thing, and this was supposed to mirror along the x-axis. Because the x remains the same and the y is shifted. Let's do it with a smaller array to understand what's going on here. Okay, let's do for x in range n, for y in range 1. Okay, so for each x, let's do print x y here. Okay, so x ranges, y is always 0, 7, 8, 9. Oh, we need to mirror, which means this needs to be like that. Next, Okay, and now we can actually do this. Okay, and that indeed mirrors on the x-axis, and now we can kind of make a more interesting thing, just to kind of see that it works. Okay, yeah, okay, and now we can define mirror on y the same way, right, or in equivalent way. Mirror on y array n equals len array for x in range, right, because we never need to mirror the middle, because by definition the middle is the middle. In range n, now the y stays the same, right, and the x changes. Y stays the same and the x changes. Now if we do a mirror first on x and then mirror on y, either that's clockwise or the other order is clockwise. So let's do this so that you can see. Okay, so I think it's the wrong order. Nope. Okay, well, I guess the mirroring trick doesn't work. So I'm not really sure, but obviously this works. I'll think about the mirroring a bit more and maybe post a blog post about it if it's interesting. Always interesting to look at other tricks, but this is probably the best way, which is by just doing like literally the cycle for every 4 items and making sure not to do any cycle again. Okay, so I think that's all we have time for today. I hope you had as much fun playing with arrays and coordinates as I did. And I guess hopefully you'll join for next stream. And if you couldn't make it for the stream, I hope that you will be able to join me to watch this on YouTube. I'll post the link later. Thank you, everybody.